本日はご対応の中、ロボット革命。
Thank you very much for joining us at the RRI, the Robot Revolution and Industrial IoT International Symposium 2022. I am Hotta from Robot Revolution and Industrial IoT Initiative. I will be serving as a moderator today. Today we will hear on the progress report on Japan-Germany collaboration based on the joint statement by Industrie 4.0 and RRI in April 2016. Currently, 3 expert fora are active and they have been holding meetings, and we'll hear from them on the progress. And first, we'll hear from the government officials before we move on to the presentation. So first, Ms. Tomoko Ina, Director, Manufacturing Industries Policy Office, Manufacturing Industries Bureau of METI. The floor is yours. Good afternoon and good evening, everyone. And thank you very much for the kind introduction. I am from the Manufacturing Industries Policy Office, Manufacturing Industries Bureau of METI. My name is Ina, and I'd like to say a few words to open day 3 of the symposium. This is the 8th symposium. I would like to congratulate the organizer for having this symposium. Today, the theme is Japan-Germany Expert Forum. So let me say a few words before you begin the presentations. So as mentioned, the initiative started in 2016, but the situation has been changing rapidly, including the COVID-19 pandemic, which has been disrupting our businesses, and the crisis in Ukraine starting this year, and surge in the commodity price, as well as the depreciation of yen. These issues have been impacting the manufacturing industry, and you have been facing a lot of challenges. In terms of policies, carbon neutrality and GX, these are the challenges. And how are we going to address these challenges through policies? These are what we are considering. And in tackling these issues, both Japan and Germany have to look at manufacturing industry, which supports our economy. We need to think about how to support them. The supply chain is connecting the world, and as we have various issues, how can we strengthen and maintain the supply chain? When we think about that topic, we need to also consider data linkage as well as the collaboration with people from different sectors and data linkage and exchange with other industries. That will be critically important. So it shouldn't happen in one country, Japan, or one supply chain alone. In the global supply chain, we must think about the collaboration and the competition where appropriate. Japan and Germany collaboration should be promoted so that both private and public members can continue working together. And I'm also looking forward to the discussions by the experts today. Once again, thank you very much for the invitation today.
ドイツ経済気候保護省ヘッサマよりお言葉をいただきます。ヘッサマよろしくお願いいたします。
Now we would like to have the words from Germany, please. Mr. Hess, please.
Dear Mrs. Ina, dear Professor Dr. Kimura,
木村様、
Dr. Hotta,
堀田
ladies
さん
and
先生、
gentlemen,
そして
Minasan.
ご参集の皆様、
Welcome to this year's
本年度の
Japan-Germany Expert
日
Forum.
独専門家フォーラムにようこそお越しいただきありがとうございます。
Germany and Japan have established a
この1
close
年間、日本とドイ
and
ツが
trustful cooperation over the last years in the field of Industrie
インダストリ
4.0.
ー 4.0 の分野で緊密で信頼できる協力関係を築くことができたことを大変嬉しく思います。本日は
For me, it is a
まさ
pleasure
にそれ
to
を
speak
示し
to
ている
you
と思い
as
ま
the
す。
co-host.
共催者として皆様にお話しできることを嬉しく思います。日独両国はさまざまな困難に現在直面しています。パンデミック、気候変動、そしてエネルギー危機、そして劇的に変化する地政学的な現実などがあります。これらはすべて世界経済に大きな影響を及ぼしています。私はインダストリー 4.0 のコンセプトというのは、こういった課題に照らしてますます重要性を増していると確信しています。グローバルバリューチェーンがより柔軟で弾力的なレジリエントなものでなければいけないということは皆さんご存知かと思います。産業のデジタル化はその扉を開く一つのきっかけになるでしょう。
It has proven to be able to lead to new forms of data-driven business in global digital ecosystems. I want to emphasize that one truth will remain. Value chains will stay global even in the future. So in the light of the current geopolitical challenges, in particular for globally working value chains, we need to take a global perspective to cooperate on topics of common interest, like standardization, security, and trust mechanisms. The foundation to succeed is the availability of data, because this is the main driver for innovation in industrial value creation. So first of all, we need access to the data. Secondly, digital sovereignty is one of the key political objectives and the precondition that companies are ready to enter database value creation. This together will thirdly lead to new digital business ecosystems. This concept of thinking is closely linked to Gaia-X, a concept that is now well known around the globe. It unleashed a paradigm shift and a culture change for industries. How to make data and services available, collated by granting data sovereignty to the users and encouraging them to share their data. And this, sharing the data in particular, can only take place in the environment of trust. In the last couple of months, Gaia-X has evolved to a new stage. It is now a framework of specifications with functional components as open source, with policy and rules and a label concept. So Gaia-X laid the foundation for lighthouse projects like Catena-X. As you may have heard on previous meetings yesterday, in a dedicated session where Catena-X was presented, how powerful this project is. I don't need to go into the details today, but Catena-X brings together key players from the automotive and supplier industry. The shared objective is to develop and implement advanced Industry 4.0 use cases. For example, in the area of sustainability, such as circular economy, product carbon footprint, and things related to that. So Catena-X is designed for openness in order to make value creation networks functional on the global scale. From my perspective, this project has a model character for other industrial sectors. So in short, Catena-X translates Gaia-X into the needs within the automotive industry, but it is more generally applicable. That is the reason why the German government plans, together with several industry associations and companies, to enlarge the process to more industrial sectors. We call this initiative Manufacturing X. So Manufacturing X is part of the new digital strategy of the German government and was announced at this year's Hannover Fair. I strongly believe this will be a future possibility for further collaboration. I'm pretty sure that German and Japanese companies are able to jointly benefit from such a cooperation. Let me stress this again. Value chains will remain global and open. We should work for that as well. Germany and Japan are like-minded, trustful partners, and we should be proud what we already achieved in our cooperation. So let's move on from this very solid foundation. Therefore, we will learn more about standardization and IIoT value chain security, as well as about business ecosystems. Now, the floor is open to the experts. Thank you for your attention. Arigato.
Hi, Hess-san、ありがとうございました。
Mr. Hep, thank you very much. Now we'd like to move on to the presentations. Today we don't have Q&A sessions, so if you have any questions on today's discussion, please go to the description box of YouTube and click on the link to go to Slido, the web Q&A website, and post your affiliation, name, and question. Without further ado, we'd like to start the presentations. The first presentation is from the Standardization Expert Meeting. The title is Toward the Future of Manufacturing, Standardization Collaboration between Japan and Germany. Professor and Dr. Fumihiko Kimura, Chairman of International Standard AG RRI, and Professor Emeritus, the University of Tokyo, and Dr. Gayko, Standardization Council Industries 4.0 Managing Director, will make the presentations. They will be introducing themselves and then begin their presentations. The floor is yours. Hello, we will be presenting on Japan-Germany Standardization Expert Meeting. I am Kimura from the University of Tokyo.
I'm Jens Gayko from Standardization Council Industrie 4.0 in Germany. And we will present our activities, and for this we prepared a presentation which will be shown by Kimura-san and myself. On the next slide, you see the content of our presentation. So we start with the objective scope of activities. Next, please. So our activity was based on an analysis of the situation. So both Japan and Germany are world leaders in the field of manufacturing technology and production systems. Both countries have made great efforts to promote smart manufacturing research, development, and industrial implementations. And here we recognized that standardization is a key for the success of smart manufacturing vision. So Internet of Things and Industry 4.0 requires a high degree of system integration across domain borders, hierarchy borders, and lifecycle phases. And therefore, we choose the approach to cooperate on standardization in the field of smart manufacturing. And in order to define a common strategy, we had the first and second edition of a strategy paper. The first edition was published in March 2017 during the Hannover Fair. Since that, we had 55 meetings of standardization experts. We had 5 published discussion papers and white papers, and several presentations during RRI Forum and Industrie 4.0 Forum at Hannover Fair. Next, please. The second and the update of the strategy paper was established in October 2020. And here you can see the details of our common strategy we defined. And we are looking now forward to see the presentation from Kimura-san to go into the details of this.
Now I'm going to share with you the basic idea of Japan-Germany standardization. Next slide, please. Today, there are many challenges such as sustainability, industrial revolution, and improvement of social life in view of advanced information of the society, which requires international response. While international collaboration is required, many possibilities for collaboration are expected. In the Japan-Germany standardization collaboration, we aim to conduct activities in this box. Toward international standardization of smart manufacturing, we will realize a detailed and sustained expert discussion forum. The biggest challenge is to identify standardization issues that will become important in the future. Use case is an effective approach to clarify requirements for standardization. I will talk about the overview of the use case analysis that Japan-Germany standardization collaboration focused on. In such developing area as smart manufacturing, instead of just coming to consensus on the mature technologies, we must lead standardization based on future vision. Application scenario is the scenario where the future target is described on a high level. Before going into the detailed technical discussion, it is important to agree on the requirements for targeted standardization. As you see in this chart, based on the business view which details the application scenario, use case corresponds to usage view and functional view. Usage view deems targeted systems as black box and analyze the relations with system stakeholders. Functional view analyzes technical processes and information exchanges with systems in more detail. It is critically important that target of analysis and application scenarios are observed closely before moving into detailed analysis in order to keep sight of the overall picture. In Japan-Germany standardization collaboration, we applied use case analysis approach through usage view and functional view to some important activities of smart manufacturing to evaluate their usefulness. The first challenge we took up was a reference model called URMMM, which centers around use case analysis. It guides development of smart manufacturing system. This model had undergone further discussion and become a basis of navigation tool which supports development of smart manufacturing system. From now on, I'm going to introduce some examples. The details have been published in a report by Plattform Industrie 4.0. Please refer to that. The example on the slide is Value-Based Service, or VBS. It considers a new role of manufacturing life cycle to create new values. In this example, you can see a business model where various services are provided as different entities between providers and users of products. In the illustration on the right, the same color represents the same organization, indicating traits of various entities. I will skip the details, but this slide shows how usage view develops into functional view in order to analyze VBS more specifically. Such analysis enables implementation of more optimal system and capturing of standardization area. AAS, or Asset Administration Shell, is a framework that represents information of various assets such as production equipment. Currently, standardization effort is undertaken. Structuring of information, consistent expression, decoupling of asset information and application, and interoperability enhancement are some basic functions of AAS. Usage view on the right is useful in evaluating the effectiveness of AAS without going into technical details. AAS is shown in red circles. Value-based service, or VBS, also refers to physical facilities. When moving from usage view to functional view and then to implementation, describing assets within the framework of AAS makes it easier to think concretely about the target system. The figure below shows an example of utilizing the AAS usage view when structuring a target system. Now, I'll talk about some of the topics we are discussing or would like to discuss in the future. In Japan-Germany collaboration, edge management or edge configuration management is under study as a practical issue that can be advanced to a demonstration experiment. In the construction and maintenance of smart manufacturing systems, the technology and operating environment of production equipment and control devices change on a daily basis. In addition, higher-level production application software is also evolving. In response to these requirements, we will consider a system that supports the realization of the system. This diagram is an easy-to-understand representation of edge management as a usage view. The edge management system is located at the top and supports the edge runtime and other functions in the edge area. In this figure, 4 types of activities are shown on the left side, assuming the typical business view from which the usage view is set up. One of the business views is shown at the bottom left, color-coded for each corresponding organization. Corresponding to the business view, the usage view is detailed as a technical solution as shown on the right. One business case is the use case of providing system optimization and plug and operate functions by utilizing collected operational data centered on system integration activities. Detailed functional views are currently being considered. One issue that is currently under discussion for specific activities is digital twin. Digital twin has become a mature technology in some areas, but it is still very insufficient in terms of its original meaning, which is the integration of the interactive and dynamic cyber world and the physical world. More systematic technological development and standardization is strongly desired. Preparatory activities for digital twin include collection and analysis of useful use cases and investigation of standardization and activities in progress in various standardization organizations, which are being discussed in the Japan-Germany Collaboration Forum. The study of a reference architecture for digital twin for a wide range of applications is a topic under earnest discussion. In addition, as a specific application, we are also working on the following issues: cross-industrial resilience, environmental friendliness, circular economy, and long-term use of products and human-machine interaction. Since the use cases of digital twins are very broad, it is necessary to classify them according to some criteria. As an example, we show here the classification by modeling hierarchy, life cycle stage, activity hierarchy, application field, and so on. The fields shown in red do not have many existing use cases and are interesting for future study. In the digital twin, the interactive and dynamic linkage between the cyber and the physical worlds is intrinsically important but has not yet been fully explored and realized. Aspects of the linkage between the cyber and physical worlds are illustrated in the figure. There are various cases corresponding to the field of application, differing in terms of whether or not a model already exists and the requirements in the direction of model coordination. Further study is needed on cases where research and development is insufficient. For a concrete understanding, a simple but interesting application is the requirement for digital twin modeling of the reuse of products and production systems. A variety of information needs to be modeled, including basic information that defines the product, information about the use of the product, information about the condition of the used product, and technical information that should be fed into the design. In order to understand these modeling requirements in detail, it is essential to consider appropriate use cases. On this slide is a use case for the reuse of batteries in electric vehicles. In order to reuse batteries for products other than automobiles, it is necessary to express a lot of information that has not yet been expressed in the past as the digital twin of the battery. This is just one example. In a Japan-Germany collaboration, we will look at related activities in Japan and Germany, set up appropriate use cases, and proceed with studies to identify important standardization requirements for the digital twin. Now I'll summarize the direction of Japan's activity in the collaboration with Germany. We have been working with the following points in mind. First, we have not been limited to standardization in a narrow sense, but have broadly pursued standardization that is necessary and beneficial to future industry and society. We have deeply considered how the different environments in Japan and Germany affect each other, even though the technologies are the same. We have also paid attention to cooperation with existing standardization organizations and other related organizations. A forum for detailed and continuous expert discussion is of great importance as a basis for these activities.
So now I will proceed to give a short overview on how the standardization strategy for Industry 4.0 works in Germany. Next slide, please. So in Germany, we have the so-called Plattform Industry 4.0. This is a platform where the different stakeholders from the ministries, from the industry associations, research and unions sit together to define the overall strategy. And for the implementation of this strategy, we have on the one hand the Standardization Council Industrie 4.0, and we have the Labs Network Industrie 4.0 for the pilot projects. So of course, for the standardization strategy, we take care. And on next slide, you can see one of our central documents, which is our standardization roadmap, Industry 4.0. In 2020, we published already the 4th edition of this standardization strategy, and it is available in English, in German, and also in Japanese. Here you can see the link. The idea is to define the overall strategy, to reduce the complexity, and to give recommendations for standardization work. Over 60 experts from industry, academia, and research are involved in developing and maintaining this standardization roadmap, and Standardization Council Industry 4.0 takes care of the secretariat and coordination. And we see this as a very important document to enable small and medium-sized enterprises to focus their resources for digital manufacturing and the standardization work. On the next slide, you can see that we published beginning of this year, or in early summer this year, a so-called progress report. This progress report shows the progress we made for the recommendations of the standardization roadmap. It is currently available in English and German. And here we give an update of the situation, also an update of the recommendations. And this progress report will serve as an input for the new edition of the standardization roadmap. The new edition is currently under preparation, and it will be published during the Hannover Fair next year, which is in April 2023. And here we will have an update of the existing chapters and recommendation for standardization work. And also we will have new or extended topics. For example, the topic of sustainability will be described more in detail, and also data spaces will be a new topic. And we are currently within our cooperation in contact with RRI office. Maybe or hopefully we will have also a Japanese translation of this standardization roadmap. Next, come to hot topics for future pre-standardized topics. We have, from our German point of view, we would like to introduce in our cooperation. The first one is a political concept. It is so-called digital product passport. For the digital product passport, the European Commission published end of March this year a draft of a potential future regulation on eco-design requirements for sustainable products. And within this draft, there are requirements for a digital product passport included. And now the question is how this will be implemented. First of all, what is the digital product passport? On the next slide, you can see this slide is copied from the European Commission because it clearly shows what it is. So it is a structured collection of product-related data with predefined scope and agreed data ownership and access rights convened through a unique identifier. It should be a decentralized system with a central registry, and the information is related to sustainability, circularity, value retention from use, remanufacturing, and recycling. So as you can see, these are also all the characteristics of a data space, which is defined here, but here with the term really related to the products and for sustainability purpose of EU Commission. The next slide goes a little bit more into detail and showing the political targets aimed with this digital product passport. This comes from tracking of raw material and their production, to also enable the manufacturers to have digital twins for their products, and to track these data through the whole life cycle. And finally, also to make this data available to market surveillance authorities, to other public authorities and public policymakers, and also to make at least some of the information available to the citizens to enable them to decide when they purchase a product, which one is the most sustainable product or fulfills the targets of the customer. And there is a relation to standardization we can see on the next slide, because the European Commission aims to use standards for the technical implementation, also the computing infrastructure of this digital product passports. And here 7 categories have been identified where standards are required. This comes from data carriers and unique identifiers to access rights management, interoperability, data storage, data processing, authentication, reliability and integrity, and also security and privacy issues. And so we expect that there will be so-called standardization mandates for the European standardization organizations. But as you will see later, our aim is to bring this to international standardization. So finally, we can say the digital product passport is a concept from the EU Commission. So it's a political concept, but technically, we think it could and should be based on technical concepts of the industry, because otherwise the industry would have the burden to implement one system for their own purposes and another one, a system for the public authorities. And here the idea is to use the same technical concept for industrial purposes and also for regulatory purposes. And from German Plattform Industry 4.0, we think the so-called asset administration shell as one type of digital twin for industrial applications can be used to fulfill all these requirements. But in order to do this, you need definitions for the content of the digital product passport for specific product categories. And here, the concept of the so-called submodels of the asset administration shell can be applied. And we think, and this is our proposal also to the European Commission, that this could be standardized internationally, because as we all know, the trade and the supply chains are globally, and therefore it is aimed to have international standards, and then these standards are referenced in Europe, in the European internal market. So there is no aim to have pure European standards for this, because that would be a very big confusion in the world market. Going a little bit into the technical concept on the next slide, we can see that in the international standardization, there is a so-called IAC CDD, the Common Data Dictionary. And this CDD is one approach to make sure of this data structures. First of all, here's a reference to the Asset Administration Shell standard, a standard of IAC TC65, where we have also, in the meantime, could establish a very close cooperation. So as I said, selected AAS submodel templates shall also become international standards. And there is already a first example. This is the so-called submodel for the digital nameplate, which is currently developed by Subcommittee 65E, Working Group 2. And here, this Working Group 2 uses the so-called IAC Common Data Dictionary, which is a database standard. And here we work closely together with another subcommittee, Subcommittee 3D, which is responsible for this database standard, to have such a very flexible database structure, and that can be used also by software there. So there is no need for humans to read these standards. And here is a screenshot of how it could look like potentially. So you have a hierarchical tree of these so-called properties and submodels. And then in the bottom, you can see the submodel digital nameplate, just as an example. So finally, I can summarize from my side that the German standardization strategy is published by the roadmap, and this is updated on a regular basis. So new topics are added for each edition. So this time, for example, sustainability and data spaces. The asset administration shell is a central element for the German Platform Industry 4.0 to digitize the industry and to enable data-based value chains. And this concept is a concept of a digital twin, and it's very generic and can be applied to many, many use cases. And one use case for this is the so-called digital product passport, which is introduced by the European Commission, or it's expected to be introduced in the next years. And here we think the concept of AAS can be very good applied to this use case, and we would like to introduce this also into our cooperation. And with that, I conclude my part, and thank you for your attention, and hand over to Kimura-san.
So let me summarize. In the international standardization of smart manufacturing, Japan and Germany have held expert meetings, shared information, conducted various activities toward standardization, and compiled reports. The most important purpose and motivation of this Japan-Germany standardization collaboration was to provide a forum for open discussion between Japanese and German experts on a continuous basis so that they can freely discuss the standardization of smart manufacturing. We believe that the establishment of an open forum of Japanese and German experts, which had never existed before, through the first phase of collaboration was a great achievement. In a second phase, we will further develop this forum and activate its activities with the aim of contributing to international standardization. Thank you very much for your kind attention.
Dr. Kimura and Dr. Gayko, thank you very much. Next, we have the presentation for Industry Security Expert Committee. The title of the presentation is IoT Value Chain Security Chain of Trust for Organization and Products. We have presentation from Ms. Ayaji Furukawa from RRI Industrial Security Action Group and Ms. Aliza Maftun from Siemens AG. Okay, Ms. Furukawa, Ms. Maftun, please.
Maftun, and I am a representative of German Plattform Industrie 4.0, and I work for Siemens in Germany as Senior Key Expert for Supply Chain Security.
Hi, I'm Ayaji from RRI Industrie
Security Action Group の
from Toshiba Corporation.
So I'm going to present the white paper that we have published together in the last Hanover exhibition this year. The title of the white paper is IIoT Value Chain Security, Chain of Trust for Organizations and Products. So first, just a brief introduction or the agenda of my talk. So I'm going to introduce and provide a background of the collaboration between Robot Revolution Initiative and German Platform Industrie 4.0. And then I'm going to talk about the motivation that led us to create this concept of chain of trust along supply chain, and then talk about that how can this chain of trust be achieved using the trustworthiness concept that we introduce in this white paper, and what are the means that are required to support that chain of trust. And lastly, how is trust transitivity related to chain of trust? And then my colleague Ayaji Furukawa would take over and talk further about the product trustworthiness and the other factors. So starting with the background, Robot Revolution Initiative of Japan and German Platform Industrie 4.0 have a very successful and a long history of working together since 2017 on various topics that concern security of industrial IoT and Industry 4.0 use cases. So last year also, we published a white paper in which we introduced a novel concept of trustworthiness expectations and capability exchange protocol, and introduced this structure of the trustworthiness profile in which the buyer can share his trustworthiness expectations to the supplier and the supplier can share his trustworthiness capabilities to the buyer. And this year we tried to extend, or the trustworthiness profile served as the basis for our work for this year, in which we published this white paper that is shown on the right. So what motivated us or what led us to the concept of chain of trust is that we realized that there are many different approaches or there are many different standards that address to particular stages of the supply chain. So there are guidelines that would guide a particular industrial vertical regarding one or the two steps of their supply chain. But what is missing is an overarching framework that would cover all these stages of supply chain. So one that would establish and measure trustworthiness of security properties, not only between immediate nodes of the supply chain, but along multiple nodes in the supply chain. And for that, we need some mechanism that could provide assurance of several nodes in the supply chain. And since there are so many different standards and there's so many different solutions and technologies available, then we really need something, a framework which would ensure that the different solutions are scalable and they talk to each other so they're interoperable with each other. And lastly, we need something that could support automated processing. So this all led us to derive the concept of chain of trust. More motivation for this work that actually led us to narrow down our intention was that we saw that in the recent year, the supply chain have grown a lot, and also the supply chain attacks have grown tremendously. So especially in this COVID times, we noticed that there were the number of supply chain attacks and also the number of successful supply chain attacks have grown a lot in numbers. And then there are different supply chain actors involved and different stakeholders involved, which uses different processes and which uses different technologies and tools. So something that could ensure interoperability or make these different processes and tools interplay with each other, that is something what's missing. On the other hand, the customers are becoming more and more aware of their rights, and also they demand different properties from the products. So for example, a customer might want to know that if they are having a product which is genuine or which is malware or backdoor free or which is protected against the attacks or which has been developed having the security lifecycle in mind. So these assurances, so I as a manufacturer would want to know that my component that I procure from a supplier is fulfilling these expectations of mine. And also likewise, I would want to assure my buyer that the product that I have prepared or manufactured and with the components that I've procured from my suppliers, they are genuine, they are integrity protected, they fulfill all the security guidelines. So we need a mechanism through which we can get these proofs or assurances from our suppliers and also provide these assurances to our customers. And lastly, we need a mechanism through which we can provide proof of compliance to the applicable standards and regulations. So for example, there's a German law coming, coming in place, it's starting next year, so 2023. It's called German Supply Chain Act. And that also requires assurances from the suppliers regarding compliance to the applicable regulations and standards. So this all helped us narrow down our intention for the white paper and narrow down our aim for the collaboration. And that is that we need to find a mechanism to support manufacturers so that they can find trustworthy components easily and can establish ad hoc trustworthy relationships with the other supply chain participants. So having this aim at mind, we adapted the definition of trustworthiness that we introduced in our last white paper. So now the adapted definition of trustworthiness is that trustworthiness corresponds to the ability of a stakeholder to make its claims verifiable along multiple nodes in the supply chain. And depending on the business context or the use case, different attributes to the word trustworthiness may apply. And the list is mentioned here. So authenticity, resilience, accountability, so forth and so forth. Then we divided trustworthiness into two broad categories. The first category is organizational trustworthiness, and the second category is product trustworthiness. So my further talk would concentrate mostly on the organizational trustworthiness, which is defined as extent to which the declared attributes of an organization can be verified by the relying party and satisfies its expectations. So based on this definition of trustworthiness, we introduce a novel trustworthiness concept in this white paper, in which we say that the supply chain must be divided into distinct trust domains, and each trust domain must identify that what their trustworthiness attributes are and what do they need to do to fulfill those attributes. And once they have defined these trustworthiness attributes for the whole trust domain, they can interact with the other trust domains at the distinct trust interactions. And these trusted interactions should also have these negotiated trustworthiness attributes between the two communicating trust domains, and then they should define that what should be done to measure or to exchange these trustworthiness attributes. And therefore, we need several different means to support these trusted interactions. First and foremost is that we need identities or secure identities, which we think can be submitted by the X509 PKI certificates or the decentralized identifiers or the concepts introduced in the self-sovereign identities. Once we have that, then we need a persistent link between the digital information and the physical entity. And this could be realized with various trust anchor technologies like physical unclonable functions or security ICs or secure elements. Once this link between the physical and the digital world is there, then we need a proof of compliance to standards or regulations that would actually serve as a proof of having a certain property. So there we think these quality certifying certificates or the security certifying certificates can come into play. And then lastly, we need a mechanism to exchange these proofs between the supply chain entities. And there we think that our trustworthiness profile and also the extended trustworthiness profile that I'm going to introduce in the next slides would come into play. Then the white paper also talks about trust transitivity, which is defined as when trust can be extended outside the two trust domains. And this leads to the concept of chain of trust, that is that the trustworthiness, that is the concatenation of trustworthiness interactions between trust domains in a supply chain. Then we also introduce 3 different chain of trust topologies. The first topology is between the 2 immediate nodes in the supply chain, when the downstream supply chain entity sends his trustworthiness expectations to the upstream supply chain entity, and the upstream supply chain entity sends his trustworthiness capabilities to the immediate downstream supply chain entity. So this chain of trust topology can be catered or can be supported by the trustworthiness profile that we introduced in the last white paper. Then the second chain of trust topology is when the trustworthiness expectations from the downstream supply chain nodes can be communicated upstream along to multiple nodes in the supply chain, and likewise the upstream supply chain entities' trustworthiness capabilities can be propagated downstream along multiple nodes in the supply chain. And for this, we are introducing the extended trustworthiness profile that I'm going to talk about in the next slide. Then the third chain of trust topology is when both trustworthiness expectations and trustworthiness capabilities can be communicated upstream and downstream along multiple nodes in the supply chain, and there is no single point of failure for trust. So this is not a very easy target to achieve, but this is what we are focusing on in the future, and we would like to achieve that. So regarding the chain of trust topology 2, we introduced this extended trustworthiness profile. So this is similar to the one that was introduced in the last white paper. So if you see the left part, the left gray part is to be filled by the downstream supply chain entity, where it first fills in his identification information and then fills in his trustworthiness expectations. And these trustworthiness expectations could be considered like compliance to different standards or compliance to different regulations, or it could also be company-specific questionnaires. And what's new here is that the buyer does not only ask the supplier to provide these compliance to these expectations, but also it needs to ask, or it can ask that the suppliers are also conformant to this particular expectation. And likewise, this yellow part on the right is to be filled by the supplier or the upstream entity in the supply chain, first with its identification information, and then corresponding to each expectation, it can say that, yes, I have fulfilled this expectation, or I do not fulfill this expectation, and then attach a proof to this conformance. And then the supplier also has this option that it can attach, or it can first say that my suppliers are also conformant to this particular expectation, and then attach a proof to it. And we do understand that here in certain scenarios, the supplier might not want to disclose that who its suppliers are, but we think that using certain technologies, we can keep that part anonymous and just be able to prove that the suppliers are also conforming to a particular expectation. So now I would like to hand over to my colleague Ayaji Furukawa for the next part of the presentation.
Now, following Aliza, I'd like to walk you through the topic of how trust should be between the organization and the product and the supply chain, particularly with regard to the trustworthiness of the product. Here is my agenda. A global supply chain network requires a comprehensive, trustworthy architecture that covers all players, regardless of their geographical location. In the next generation manufacturing global supply chain, product manufacturers must develop products that meet rapidly changing customer needs, collaborate among suppliers to develop products in a secure manner. They must also leverage the internet to find the right suppliers quickly as they need. So the starting point for discussions between Japan and Germany was that what is that we're looking for when it comes to trustworthiness to reduce risks in transaction under these circumstances. We believe that trustworthiness corresponds to the ability of a supplier to meet in a verifiable manner the expectations of a potential counterparty with respect to security and risk management in the supply chain and value chain. In other words, trustworthiness is the ability to meet expectations. As Aliza mentioned earlier, in our white paper, we discussed organization and products in terms of trustworthiness in the supply chain. Now, let me focus on the trustworthiness of products in my presentation. In the white paper, we define product trustworthiness as the ability to have the declared attributes of the product validated by the recipient stakeholders and to meet their expectations. Now, let me explain the reason why RRI decided to focus on product trustworthiness. A company will develop a product and then it goes through multiple processes to reach the end user, including component integration, testing, and certification. Each party in the supply chain has its own manufacturing process, and it can be quite cumbersome for end users to get the accurate data of the product and whether the product meets their expectations. Now, as we witness growing number of attacks on supply chain, it is also essential to track the development life cycle of a product to ensure that it is sourced from a trusted party, with components from trusted sources, and complies with applicable standards and regulations for a specific market and free from backdoor or malware. For example, a manufacturer produces a product using off-the-shelf products and components sourced from a new supplier in another country that they've never worked before. The manufacturer wants to verify the reliability of these parts before using them to manufacture its own products. They would also want to give their customers a peace of mind that their products are reliable by using verified and reliable components. As we expect such needs to grow down the line, we wanted to establish a mechanism to easily and efficiently verify the trustworthiness of a product. RRI decided it's best to discuss with our partners in Germany as to how the trustworthiness of a product should be viewed from a cybersecurity perspective. Now, when considering the trustworthiness of stakeholders in the supply chain, such as suppliers and buyers, there are two main categories to consider. One is the trustworthiness capacity of the organization. For example, whether or not there is governance and management around security. The other is product-related trustworthiness. It's about their ability to deliver products of the right quality, cost, and in time. So these were the two abilities we paid attention to. For example, the yellow area represents the pre-contract phase, and the red is the post-contract phase in this diagram. First, when a manufacturer selects a supplier to procure parts, they check whether the supplier meets the security criteria, as well as their governance and risk management practice. That is, the trustworthiness of the organization to see if they satisfy their expectations. The manufacturer asks the supplier for the necessary information according to the business case, like ISO 62701 or 624441, etc., and verifies the supplier's response, selects an appropriate supplier, and contracts with the supplier. The manufacturer then replaces the purchase order. If there are any insufficient items, the manufacturer can make additional requirements based on the trustworthiness profile, for example, to comply with 624442. When products are delivered from suppliers, they will check the trustworthiness of the products to ensure that the items requested in the contract have been complied with. We have organized the overall picture of organization product trustworthiness and the supply chain as you see in this chart. When a product is delivered from a supplier, the manufacturer verifies the reliability of the product based on the supplier's organizational trustworthiness profile and the supplier's claim of product reliability capability. Next, we will explain how we reviewed the relationship between organization trustworthiness and product trustworthiness. When interacting with a new business partner across borders and companies in the supply chain, when selecting a suitable supplier, the buyer first checks whether the organization meets the buyer's trustworthiness expectations. By referring to the trustworthiness profile. The supplier's organization's trustworthiness profile, as verified by the buyer manufacturer, will serve as the condition for verifying the trustworthiness of the products that the supplier will deliver to the manufacturer after the contract is signed. In other words, the elements of the supplier's organizational trustworthiness verified at the time of supplier selection serve as elements to verify the trustworthiness of the products delivered by the supplier. Or we could say that we thought that the trustworthiness will propagate. In Germany, as explained earlier, this is called trust transitivity in English. If there is a proof of the organization's trustworthiness, then the organization's products and manufacturing business process will also be trustworthy. In this way, we thought that the trustworthiness of an organization leads to the trustworthiness of its products. As Aliza explained earlier, in our discussions with Germany, we introduced the concept of chain of trust, which means that all relationships in the supply chain from upstream to downstream are trustworthy. We call this chain of trust. A chain of trust is where the trust extends beyond the two trusting areas in which trust has been established. In supply chain, we position the chain of trust as the transfer of trust capabilities upstream and downstream. As shown in this figure, there are three possible topologies or steps to realize a chain of trust in a supply chain. I have just explained about the chain of trust topology 1, 2, and 3, or Aliza have explained that. Now let me explain chain of trust topology 3 in more detail. The third chain of trust topology represents the case where the trustworthiness capability of all nodes and the supply chain is tracked and can be traced upstream with appropriate permissions at any stage of the supply chain. This implies two-way trust along the supply chain. As shown in this figure, both trust expectations and capabilities are propagated downstream and upstream in the supply chain. In recent years, suppliers have begun to demand trustworthiness from manufacturers in the way parts are used. Specifically, this is specified in terms such as not incorporating the component into an improper product. Such trustworthiness is propagated from upstream to downstream. This chain of trust is particularly effective when a supplier wants to ensure that products manufactured with the supplier's components will be sold only in the supplier's intended market and will comply with applicable regulations in the country. Suppliers will also increasingly need to ensure that the parts they manufacture are used as expected by their suppliers and that the suppliers are complying with social rules such as human rights issues, for example. As various regulations and rules are applied in different markets globally, we believe that it is beneficial for suppliers to be able to confirm the market to which their products are applied and to prove that they are doing business and in compliance with social rules. If this third chain of trust can be realized, we believe that trustworthiness of the entire supply chain will be established. Lastly, we will ask Aliza to explain about the future work.
Aliza, could you please introduce our future work?
Yes, thank you, Ayaji. So in the future work, we would like to investigate that how can we keep certain aspects of the proof anonymous while ensuring the trustworthiness capabilities along different nodes in the supply chain. So we would like to investigate different technologies with which this can be supported and how can the trade-off between the technological solutions with the anonymity be solved. So this is one topic of our future work. And the second topic is the reliable subject identities, which are essential for identification and authentication, not only for the products, but also their corresponding capabilities. That is the quality certifying certificates or the security certifying certificates. And the third aspect that we would want to concentrate on in the future is the chain of trust topology 3, which states that there should not be a single point of failure in the trust, and the supply chain of trust should be resilient enough so that it's not broken by if one of the entity drops out in the supply chain. So our goal is to implement as much as possible robustness and resilience by technical means, which cannot be disturbed by any single stakeholder in the supply chain. So this is not a trivial target, but we are confident that this can be done using different technologies that are coming into play in the future. So thank you.
Thank you very much.
Thank you.
Furukawa-san, Aliza-san, thank you very much. Now we come to our last presentation, which is made by Business Model Transformation AG. The title of the presentation is Business Ecosystem in Industries. Professor Dr. Ulrich Löwen from Plattform Industry 4.0, AG6 Siemens, and Mr. Shuhei Sugiya from Future Corporation will make the presentation.
Good evening. Let me first introduce myself. I'm Shuhei Sugiya. I provide consulting services on digital aspects and strategies and help create new business models at Future Corporation. I also work on designs at a company called Innovation Lab. This fiscal year, I serve as a chair in RRI's working group to understand business models. So I'd like to make a presentation from this position today on day 3. We only have a short time, but I hope you will stay with us until the end.
I am Ulrich Löwen from Siemens. I'm working as a senior principal engineer, and I am member of the working group Digital Business Model of Plattform Industrie 4.0. Thank you.
First, I'd like to make my presentation from Japan side. The theme of this session is business ecosystems in industries. We will be presenting initiatives in Japan and Germany. Next slide, please. First, on our understanding of the current challenges. This is a slide from International Symposium in 2018, where Dr. Kagaman proposed this idea. It's been said for quite some time that the platform economy had been developed. But we see skewed distribution of wealth in such platforms as GAFA in the US and Alibaba and Tencent in China. In B2C, while winners and losers are already clear, what should Germany and Japan do? That was the question raised by the doctor. On the other hand, in B2B, such competition is just starting, which means for Japan and Germany with strong manufacturing capabilities, there are still opportunities in B2B platform area. So Dr. Kagaman encouraged us to learn and work together on this end. Japan side all in all agrees on this idea of creating B2B platform and business ecosystem. But what are the challenges to achieve this? And is it feasible to begin with? To understand that better, this fiscal year, RRI conducted a questionnaire targeting participating companies and asked what challenges they are facing. The biggest challenge that many companies feel they are facing is indicated in blue in the graph, which is difficulties in collaborating with competitors using digital technologies. A little less than 50% of respondents said this is a challenge. Moving on to the orange portion. Well, in order to collaborate on a platform, we must generalize business models using the same language and share a system together. But many feel that Japanese companies are not very good at generalization or conceptualization. So many respondents felt that this is another challenge. Another challenge is human resources. Securing human resources in the field of manufacturing is still a competitive area. But these are the challenges, and so overall, yes, we want to create an ecosystem, but there are still many challenges to tackle. That is our understanding of the position of Japanese companies. And there are many more things that we have to do. It's not just about creating individual business ecosystems, but today, expectation toward business ecosystem platform is increasing. The expectation is that carbon neutrality and circular economy will also be achieved using such business ecosystems. It means we must solve these social issues while succeeding in our business. Next slide, please. And the most symbolic of such idea that is proposed by the Japanese government is Society 5.0. I know that the audience are quite familiar with this concept, but just to recap, it is a human-centered society where both economic growth and the resolution of social issues are achieved by integrating cyberspace and physical space. Japan is introducing this concept to the world. So I believe our mission is to create successful business ecosystem and create Society 5.0 at the same time. We must achieve this together. Next slide, please. So, based on our understanding of these challenges, last year, we discussed with our German colleagues on what should be done to tackle them. One of the topics we discussed was the need to have a vision of platform ecosystem. And we also discussed the need to understand the benefit and motivation of creating such a platform, and also how to create one. These are the areas that we must discuss and research on. To this end, we also discussed last year that standardization, open innovation, and servitization must be considered as well. To facilitate this, Japanese colleagues realized that we must deepen our understanding on the business ecosystem itself. So for this reason, we have been reading this book called The Death of Competition by James F. Moore in 1996. It's a book from a while ago, but it's also the very first book that shed light on business ecosystem and garnered attention around the world. So that's what we have done so far. From now on, spending the rest of the time for my presentation, I'd like to talk about what we thought as we read the book, as well as our understanding on what should be done going forward. We spent 6 months in 2022 to read The Death of Competition with 3 objectives. First, of course, is to fully understand the content of the book. It's a book with several hundred pages in English, so we read it in turn to deepen our understanding. Second was to organize our learning from the book, because we would have to understand it, learn from it, and take action. Third was to discuss how we could enhance Japan's competitiveness by building such platforms. Fortunately, Moore published another book in the latter half of the 2000s, so we read that book as well to discuss what to do in the future. The work was done by 11 stakeholders from manufacturing industry. We call them 11 samurais. They got together and had very lively discussion bi-weekly. It will be compiled into a report. Currently, we are finalizing the report, so once it's published, you will be able to read that. But for today, I'm going to introduce just some parts of the report. First, let me share with you our takeaway from the book. There are 4 items. First, throughout the book, Moore consistently argues that the business ecosystems and biological or ecological ecosystems are similar. He also emphasized in this book the importance of co-evolution. In the world of business, if an individual company bullies a subcontractor, for instance, the company cannot grow. So a system that enables co-evolution is necessary. That's what we learned. Secondly, we learned about distinct stages, the concept of distinct stages. There are 4 stages, namely pioneering, expansion, authority, and renewal or death. To create an ecosystem or platform in the future, we learned that it is important to understand the stages and take action accordingly. And the book also talks about what needs to be done in detail in each stage. So we'd like to translate the learning into actions. The third point is actually something that the members discussed a lot about, which is the difference between the business and biological worlds. We believe there are 3 major differences. 1, existence of a leader. 2, control of the surrounding environment. And 3, whether there is an end to the ecosystem or not. First, existence of a leader. In case of business world, it was emphasized back in 1996 that the business ecosystem is built, designed, and materialized by a leader in each stage. That is a clear difference from a biological world where a leader does not exist. So this is a common understanding among the members. Another difference is the control over surrounding environment. Organisms cannot easily change the surrounding environment drastically, but in the world of business, through deregulations or international standardization, we can control the surrounding environment. So we must be aware of this as we form an ecosystem. Also, a business ecosystem has a shorter cycle than a biological ecosystem, so we have to be conscious of the end of the ecosystem. The next point, the fourth point, is the ecosystems are mainly centered around either business, environment, or society. We believe that if we are to focus on the societal issues, then we must also consider the relationship between the three. Back in 1996, awareness on the environmental issues was already rising. It was mentioned at the very end of the book. So this is something that needs to be delved into. I'll talk about this in more detail on the next slide. To solve those social issues that I mentioned at the beginning, how are we going to build a B2B business ecosystem? There are 3 points. We have 3 learning in this. And first, as we saw on the previous slide, ecosystems of business, society, and environment must be coordinated. The need for such coordination is increasing. Therefore, we must consider the point. Environmental limitations are increasing in doing business, and I'm sure that you have been sensing that. So we must understand the value of the environmental ecosystem as well as global social ecosystem when designing a business ecosystem. That is what's expected of us. Secondly, business ecosystems as a means to solve challenges such as circular economy and environmental issues are growing. Moreover, they have to be solved on a global scale. Catena-X and other data sharing schemes that were discussed in the symposium are just some of these examples. In any case, we like to form business ecosystem with the idea of solving social issues through business. Third is more about technologies. With the advent of Web3 and blockchain technology, distributed technologies are spreading. We believe that distributed landscape in digital ecosystem can be materialized, and as a result, that the ecosystems will become more and more like ecological systems. In 1996, presence of leaders was deemed quite important, but with the advancement of technologies, distributed and leaderless ecosystems that cover the combination of business, society, and environment are becoming feasible. So we have to take action so that such a design or mechanism will be made viable. Today, we will hear from our German colleague on their perspectives. And going forward, while understanding the nature and changes of business ecosystem, we'd like to work together between Germany and Japan to develop business ecosystems for solving global challenges. That is the shared wish among the 11 members. Instead of ending the journey by just getting the knowledge, we intend to take action and hope to do so together. That is all from my side. Thank you very much for your attention.
Ulrich, please presentation in German part.
Next slide, please. I would now like to illustrate our common topic, business ecosystems in industry, with a concrete example. It is a realistic example, but still under development. I will focus on a business perspective. I would like to illustrate what options the various business participants have in such a business ecosystem. The various business participants will decide on their own business model and must ask themselves to which extent they will align their business model with the other participants and where they compete with them. The example is sustainability. I would like to focus on one aspect, namely the declaration of the product carbon footprint. Next slide, please. A core business stakeholder in this business ecosystem is the manufacturing company that wants to declare the product carbon footprint to its customers. The manufacturing company is represented on the left in the value network by an orange icon and the customer by a yellow icon. The manufacturing company must determine the so-called Scope 1, Scope 2, and Scope 3 contributions to the product carbon footprint, then add them up and then make the specific value available to the specific customer. As part of the Scope 1 calculations, the manufacturing company must determine how many direct emissions are caused by the company to manufacture the specific product. As part of the Scope 2 calculations, the manufacturing company must determine which resources, such as energy, are required by the company to manufacture the specific product. The determination of the Scope 1 and 2 contributions requires a concept of how to allocate the overall emissions and resource consumption of a manufacturing company to the specific products. This can be challenging, but I do not want to look at that in the following, but I will limit myself to the Scope 3 contribution. Scope 3 includes the contribution caused by the purchased components. So you need the product carbon footprints of the supplied components from your suppliers. One could consider corresponding databases that provide such values. Such information is called secondary data. However, secondary data only reflects the facts imprecisely because, for example, the transport from the supplier to the manufacturing company is only considered as a lump sum. However, we want to work with the primary data, thus with the specific product carbon footprints of the specific components supplied, which the suppliers make available individually to their components. Another challenge arises when it comes to the values of the product carbon footprint. The customer must trust the manufacturing company, and the manufacturing company must trust its suppliers that the declared values are trustworthy. In contrast to product properties such as weight, dimensions, or performance, which a customer can measure and check independently, a customer cannot do this with the product carbon footprint. And this necessary trust of a customer in a product supplier must be considered when designing the business ecosystem. Next slide, please. In the business ecosystem under consideration, the manufacturing companies in the supply chain formulate requirements for other partners in the business ecosystems who offer the manufacturing companies their products and services. One of these partners is a software application provider that offers software for managing product carbon footprints. This company is symbolized by a red icon in the value network on the left. The software application provider gives the manufacturing companies the following value proposition. It supports the manufacturing company in maintaining the product carbon footprints declared by the suppliers while ensuring trustworthiness. It also supports the manufacturing company in making the product carbon footprint declared for the product available to the customers in a trustworthy manner. Next slide, please. To address the core issue of trustworthiness, let us consider the additional business role of a trustworthiness services provider. It is symbolized by a purple icon in the value network on the left. First, we assume that the manufacturing company has no contractual relationship with this service provider, but only the software application provider uses these services. The core value proposition of the trustworthiness services provider is to manage information from various sources in such a way that it can be verifiably passed on to others in an unaltered manner. To make this abstract view more concrete, I would like to give the following examples. Z-Green from Siemens is an example of such a software application. And the Estanium network is an example of such a trustworthiness services provider. Next slide, please. After these considerations on the basic setup of the business ecosystem, we now want to briefly discuss an option of a software application provider regarding its role in the design of the business ecosystems. One must assume that there will be several software application providers with comparable functionality on the market, represented on the left by two software application providers, one symbolized by a red icon and one by a light red icon, each using a trustworthiness services provider of their choice. A manufacturing company can freely choose which software application provider on the market it wants to use. The example shows that the manufacturing company and the customer have opted for one provider and a supplier for another provider. Manufacturing companies will require software application providers to make their software applications interoperable. A manufacturing company simply will not accept having to integrate several software application providers. Otherwise, the business ecosystem has no basis to exist from an economic point of view. Thus, a software application provider can use his degree of supporting interoperability to position himself on the market. One of his design levers from a business perspective is to create unique selling points in the market through the supported degree of interoperability. Next slide, please. Now we want to discuss an option of a trustworthiness services provider regarding his role in shaping the business ecosystem. The trustworthiness services provider can establish himself as an intermediary between the manufacturing company and the software application provider. In this case, the trustworthiness services provider expands its offering by a marketplace for software application providers. The consequence of this is that the manufacturing companies no longer obtain the software application directly from the software application provider, but via the trustworthiness services provider. Particularly software application providers who hardly have access to manufacturing companies will see this as an opportunity. For example, Catena X is pursuing the goal of operating such a marketplace in which, among other software applications, Z-Green from Siemens will be offered. Next slide, please. What I would like to illustrate in this example, there are independent forces in the market who will all try to shape the business ecosystems in their interest. Various options are offered to the manufacturing company. They can obtain the software application either directly from a software application provider or via the marketplace of a trustworthiness services supplier. They can choose from various software application providers, but also from various trustworthiness services providers. A software application provider must position itself in relation to its competitors. For example, as explained by specifically addressing the issue of interoperability. He must also consider which sales channel to use to address his customers, directly
and/or via one or more marketplaces of trustworthiness services providers. The challenge of the trustworthiness service provider will be to acquire the largest possible group of customers for its services. A positioning as an intermediary will probably only be economically successful if the trustworthiness service provider can assert itself against its competitors in the market. I would like to emphasize once again that the forces described act independently of one another. But ultimately, the market will decide which of the different strategies of the individual business stakeholders will prevail. Next slide, please. Of course, there are other options. For example, the software application provider could differentiate itself through its specific functionality and features. He could also cleverly segment his market and, for example, offer simpler or lighter solutions to small companies. A trustworthiness service provider could accelerate the scaling of its offering by supporting complementary use cases. For example, in addition to the topic of sustainability, he could also support similar use cases such as traceability or capacity and demand management by offering software applications in his marketplace that support such use cases. Catena X is an example which uses this possibility. In Germany, we are observing that the technical discussions are being conducted in a very comprehensive and committed manner. However, the discussion on how the specific technical solutions can then be used commercially and lead to economic success really needs to be stimulated. Of course, the concrete business ecosystem discussed is still in an early stage of development, both in terms of the regulatory framework and the commercial implementation in the market. But we should shape this promising topic now and not forget, and now I repeat myself, ultimately the market will decide which of these approaches will prevail economically and sustainably. Next slide, please. Next slide. I would now like to summarize our session. All the examples we presented are business ecosystems. They have a different setup, and it is the responsibility of each business stakeholder to determine what role they want to play in that business ecosystem to shape the business ecosystem. I would like to mention that the approach presented is in line with the report that we have published together as German and Japanese experts 2 years ago. We will continue to discuss the topic of business ecosystems. Specifically, the German expert will further elaborate the presented example and then discuss it with the Japanese experts. And vice versa, the experts from Japan will continue to consolidate their analysis and then share them with the German experts. We then want to bring these two perspectives together in a joint white paper, but we still must discuss the specific content and schedule. I am convinced that by combining these complementary perspectives, we will bring the topic of business ecosystems in industry forward in the long term. Next slide. Thank you.
ルーペン様、杉江様、ありがとうございました。
Dr. Löwen and Mr. Suge, thank you very much. And dear presenters and participants, thank you for joining us in today's event. RRI is striving to contribute to identifying the collaboration areas and developing human resources toward industrial development. Today's presentations covered discovery of standardization issues, which will be critical in the future, as well as trustworthiness of supply chains and business ecosystems. All these challenges require open international collaboration rather than closed efforts by individual companies or countries. RRI is connecting Ms. Ina from METI, who opened today's event, and 500 RRI member companies. I'm sure you are aware that Industry 4.0 from Germany have had an impact on Europe and the world. I met with Mr. Heth in Berlin 4 years ago when I was with Hitachi, so I'm delighted to see him again in a different capacity today. As you saw in the presentations, RRI and Industry 4.0 from Germany have a lasting and strong relationship. I believe it is important for both Japan and Germany. We'd like to continue our collaboration so that we can contribute to the development of this area. I hope the discussions and the symposium were useful for you too. This concludes today's program. Thank you very much.